Hey guys, welcome back. This is video 2. Draw the Lewis dot structure for H2O2 and assign all formal charges. Set it up really easy for you. First off, we need to sum up all the valence electrons. Well, we know that hydrogen has one valence electron. There are two of them, so we need another one valence electron. There's two oxygens, so we need 6 plus another 6 gives us 14 valence electrons. Now we need to connect all of them with a single bond. So we do oxygen, oxygen, to a hydrogen, to a hydrogen. Well, now we need to use these 14 electrons, and we'll begin by completing the octet for all the atoms. Well, if we look at this hydrogen, it has one valence electron, it's satisfied. This oxygen has 2, 4, 6, 8, it's oxygen. This atom is satisfied for the octet. But also if we look, it really only has one valence electron that it's sharing in this bond. 2, 4, 5, 6, it still has all its valence electrons. The same for this oxygen, it's satisfied, and this hydrogen. So now we need to assign the formal charge. Well, hydrogen has one valence electron minus 0 non-bonded electrons minus half the number of bonded electrons, which are 2. I like to think of non-bonded electrons as the dots and bonded electrons as the dots that make the bond. So we have 2, but then here we have it has no non-bonded electrons, so 0 gives us 0. So both hydrogens have formal charge of 0. Next, oxygen has 6 valence electrons minus non-bonded electrons, which are 4 minus 1/2 of bonded electrons, which is also 4 equals 0. So both hydrogens and both oxygens are 0, and the formal charge with that is 0 is the resonance structure we want to use, and therefore this is the best resonance structure. Second example says, draw the Lewis dot structure for AS033-. Well, we need to sum up all of our valence electrons. AS is in group 5, so it has 5 valence electrons, plus oxygen, also in group 6A, has 6 valence electrons, but there are 3 of them, so we need to multiply it by 3. And we also have 3 extra electrons, so we need to add 3. When we do the math, it gives us 26 valence electrons. Now we need to connect all the atoms with a single bond. Well, AS has 3 oxygens attached. Now let's complete all the octets for the atoms. At this point, I like to count. Make sure that I haven't used over 26. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 24, but we need 26. So we need to put any leftover electrons on the centermost atom. Now we have 26. So let's make sure our octet is satisfied. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. Everything is satisfied. So now we need to do the formal charge. Formal charge for AS, it's in group 5, so it has 5 valence electrons, minus non-bonded electrons, which is 2, minus half the bonded electrons, which if we look is 2, 4, 6. That gives us 0. So now for oxygen, let me just draw this up here a little easier maybe for you to see. It has 6 valence electrons, minus non-bonded electrons, which is 6, minus 1/2 the bonded electrons, which is 2, gives us a formal charge of -1. So all of these oxygens have a formal charge of -1. That gives us an overall charge of -3, which we need these brackets to show. Well, the negative charge is on the most electronegative atom, being oxygen, so this is our best resonance structure.